submerging ourselves into the substantial expanse of the universe. Human beings have lengthy contemplated whether or not we're certainly the number one species able to thinking of remote worlds. We have checked out the stars, speculating approximately the cap potential for existence past our small blue planet. This functionality has in the long run materialized. NASA's administrator has said that the James Webb Space Telescope, JWST, has captured some things superb at the brink of our substantial universe. The JWST has targeted on Proxima B, the nearest but probably livable exoplanet to Earth. While the concept of an inhabited town on Proxima B has been a lengthy status one, we nevertheless do now no longer recognize for sure. The trendy James Webb discovery suggests that the synthetic illumination from Proxima B's cityscape has been detected and the exoplanet's atmospheric composition has been analyzed. According to NASA's administrator, the JWST may have detected symptoms of existence on Proxima B, an exoplanet placed about 4.2 mild years from our Sun system. In Proxima, B has turned out to be exquisite for its cap potential habitability. This exoplanet orbits Proxima Centauri, a crimson dwarf big name a lot smaller and cooler than our Sun discovered in 2016. Proxima B is living withinside the livable region, additionally called the Goldilocks zone, round its big name in which situations should permit for liquid water, a critical detail for existence as we recognize it. Proxima B's proximity to Earth and its role withinside the livable region have generated sizable hobby in its cap potential to help existence. However, it's miles crucial to apprehend that the habitability of an exoplanet is a complicated puzzle related to numerous elements. Proxima B is classed as an exoplanet with a mass approximately 1.3 instances that of Earth and has an orbital length of about 11.2 Earth days, which means it completes one orbit round Proxima Centauri in that time. Yet, the truth that the planet is Earth-sized and orbits a crimson dwarf does now no longer assure that its miles a real analog of our global, in which we should probably live. And in the habitability of Proxima B is inspired through numerous elements, which include the planet's ecosystem, which acts as a defensive protect and performs an important function in regulating temperature and helping existence. Currently, the specific factors of Proxima B's ecosystem stay uncertain, making it tough to definitively decide its habitability. The JWST researchers are at the vanguard of exploring the thriller of remote worlds like Proxima B. Their relentless pursuit of expertise drives them to increase modern strategies and devices to observe the atmospheres of exoplanets, aiming to find symptoms of interest beneath the floor of remote worlds. One such device with first-rate promise on this undertaking is the James Webb Space Telescope. The JWST, with its superior era, represents a sizable bounce ahead in area research, imparting the capacity to look deep into the universe and resolve its secrets and techniques. Equipped with current instrumentation and era, this first-rate observatory is well-placed to cope with urgent questions in astronomy, which include the look for livable worlds and symptoms of extraterrestrial existence. And one of the important goals of the JWST is to observe the atmospheres of exoplanets with a particular cognizance on detecting biomarker molecules that would imply cap potential existence. To obtain this goal, researchers have advanced state-of-the-art observational strategies that take benefit of the telescope's extraordinary cognizance and sensitivity. One such technique includes gazing transits, a phenomenon in which an exoplanet passes in the front of its host big name as visible from Earth. During those transits, a part of the big name's mild passes via the exoplanet's ecosystem earlier than attaining our telescopes. By reading this transmitted mild, astronomers can benefit treasured statistics approximately the composition and houses of the exoplanet's ecosystem. The JWST suite of devices is designed to seize and examine the spectral traits of exoplanetary atmospheres at some point of transits. Spectroscopy, the observe of mild separated into its constituent wavelengths, is critical to this method. By measuring the absorption or emission of precise wavelengths of mild, scientists can discover the presence of key molecules which include water, methane, carbon dioxide, and oxygen in the exoplanet's ecosystem. A precise hobby are biomarker molecules, which can be chemicals that would sign the presence of existence on a far-off global. Biomarkers consist of molecules like oxygen, ozone, and positive natural compounds, which include methane and ammonia. These molecules have herbal origins on Earth and might function robust proof of existence if detected in an exoplanet's ecosystem. The JWST's extraordinary sensitivity and spectral precision allow researchers to hit upon even hint quantities of those biomarkers, imparting important insights into the potential habitability of remote worlds. And then, despite the telescope's good-sized subject of view and lengthy statement instances, precise observations of severe transits decorate the statistical importance of the findings and decrease uncertainties inside the data. In the case of Proxima B, the JWST holds first-rate promise for unlocking the secrets and techniques of its ecosystem and losing mild on its proper potential for helping existence. As the nearest recognized exoplanet to Earth, Proxima B gives a completely unique possibility for precise analysis. Using the JWST's effective capabilities, scientists intention to find information about its chemical composition, temperature, climate, and environmental elements. They might be searching for symptoms of key molecules that would imply the presence of existence, which include water vapor, carbon dioxide, and probable oxygen. And in the JWST's capacity to observe the atmospheres of remote exoplanets represents a critical leap forward in our quest to recognize the superiority and nature of existence inside the universe. By leveraging the telescope's unrivaled capabilities, researchers are poised to make groundbreaking discoveries that would remodel our information of astrobiology and the look for extraterrestrial intelligence. Another important aspect influencing habitability is the presence of water. Although Proxima B is in the livable region, figuring out whether or not it has enough quantity of water to be taken into consideration appropriate for existence is crucial. Water is an essential thing of the habitability puzzle, and scientists are looking for proof of liquid water at the planet's floor, whether or not inside the shape of oceans, lakes, or rivers. Signs of water in different states, which include ice or vapor, also are taken into consideration, as water availability is critical for maintaining organic techniques and is seen as a key indicator of habitability. And in the presence of Proxima B increases questions on its environment. Researchers have to additionally look at elements which include temperature, atmospheric pressure, and geological interest on Proxima B to evaluate whether or not the planet is inside a feasible variety for existence to thrive. Extreme situations which include severe warmth or bloodless can assign the potential for survival, whilst volcanic eruptions or seismic interest should disrupt habitability. However, balance is an advantageous sign. Proxima B is conceived to be in a tidally locked state, which means that one aspect of the planet stays in perpetual darkness, whilst the opposite aspect is continuously illuminated through its big name. The stark evaluation among the illuminated and darkish aspects should create temperature gradients and situations that could have an effect on the planet's habitability. And these are simply a number of the elements that researchers are thinking about inside the look for livable planets. Scientists are analyzing the chemical composition of Proxima B to observe the presence of natural compounds, which include amino acids and different materials crucial for existence. They also are assessing whether or not the planet gets enough electricity from its big name or different resets to help organic techniques and permit existence to increase, reproduce, and flourish. Despite those investigations, questions stay approximately whether or not Proxima B certainly possesses all of the vital factors to be taken into consideration a livable planet. Is there concrete proof to help this? And the discovery of Proxima B in 2016 turned into a sizable achievement. Astronomers used the High-Accuracy Radial Velocity Planet Searcher, HARPS, to hit upon the diffuse gravitational pull of an exoplanet orbiting Proxima Centauri, our nearest neighboring big name. This high-precision spectrograph, running on the La Silla Observatory in Chile, has been instrumental inside the discovery of severe exoplanets, which include Proxima B. The HARPS device works the usage of the radial pace technique, additionally called Doppler spectroscopy. Its capacity to hit upon exoplanets comes from measuring the tiny adjustments inside the big name spectrum due to the gravitational impact of an orbiting planet. These adjustments, called radial pace or Doppler outcomes, result from the big name's mild wobble because of its gravitational interplay with its orbiting planet. HARPS is an effective device that has revolutionized the sphere of exoplanet detection. By harnessing the energy of precision spectroscopy, HARPS permits astronomers to hit upon minute wobbles in a big name's movement due to the gravitational pull of orbiting planets. This technique, called the radial pace technique, has validated powerful in coming across exoplanets, which include Proxima B, the nearest recognized exoplanet to Earth. At the coronary heart of HARPS is its high-stage optical fiber system, which serves as the conduit for shooting starlight and transmitting it to the spectrograph's devices. This fiber optic era permits astronomers to gather starlight and examine its spectral signatures with first-rate precision. As the starlight enters HARPS via the optical fibers, it undergoes a method of dispersion in the spectrograph. This dispersion separates the incoming mild into its constituent wavelengths, developing a spectrum that carries treasured statistics approximately the big name's composition, temperature, and movement. By analyzing the big name spectrum, astronomers can hit upon diffused adjustments inside the positions of spectral lines, which imply versions inside the big name's pace alongside the road of sight. These pace shifts are due to the gravitational impact of an orbiting planet because it movements round its host big name. By measuring those shifts over time, astronomers can infer the presence of an exoplanet and decide its houses, which include its mass, orbital length, and eccentricity. The key to HARPS's fulfillment lies in its extraordinary sensitivity and accuracy. The device can hit upon pace adjustments as small as some meters consistent with second, equal to the velocity of a brisk walk. This stage of precision permits HARPS to hit upon the gravitational outcomes of even small Earth-sized planets orbiting remote stars.